Welcome back. Part 2 of Unit 5, looking at chemical compounds. In Part 1, we talked about what the three chemical compounds are. Part 2, we're going to name your chemical compounds. Just a quick little reminder for ionic versus covalent. We're not going to talk about metallic in this video because you don't have to worry about naming metallic bonds. But ionic is metals and nonmetals. Covalent, nonmetals, and nonmetals. And now what's cool is that the metal will always come first. So if your first element is a metal, you know you're dealing with an ionic compound. If your first element is a nonmetal, you know you're dealing with a covalent compound. So let's check out how we write formulas for ionic compounds. First off, ionic compounds, the whole formula has a neutral charge. You got to make it neutral. So you have to fix your charges so that it becomes neutral. So it shows your types of atoms and how many of each atom. That's just a chemical formula in general. To write an ionic compounds formula, you need the two types of ions, piece of cake, and then you need, and don't worry about pink and blue, and you need the charge on each ion. So let's look at some examples here. We have sodium and we have fluorine. Now what's cool is sodium gives up one electron, fluorine takes one electron, so you only need one of each to make it happy. Bam, sodium fluoride, NaF. Barium and oxygen. Barium gives up two electrons because it's in group 2. Oxygen takes two electrons because it has 6 valence electrons in group 16. They're both happy with each other, BaO. Now it gets a little bit different here when we have sodium and oxygen. Sodium wants to give away one electron, oxygen wants to take 2. So to be happy, oxygen is going to need to find 2 sodiums because it gets one electron from one sodium, one electron from another sodium. So sodium and oxygen are going to make Na2O. Let's look at barium and fluorine. Barium wants to give up 2. Fluorine only wants to take 1. So barium is going to have to find 2 fluorines to get happy because barium wants to give away 2 electrons. Now what's cool is you don't have to think about everything I just said every time, because if you look at the pattern, the 1 gave us 1 fluorine, the 1 gave us 1 sodium. Look down here. The 2 gave us 2 fluorines, the 1 gave us 1 barium. So this is called the crisscross rule. The crisscross rule, the charge on your first thing, your cation, is going to become the subscript of the anion. The charge on your anion, the second thing, becomes the subscript of the cation. So the charge on one becomes the subscript of the other, and then once you crisscross, you reduce to lowest terms. So this is why for barium oxide, it's not 2 and 2. We reduce 2 and 2 to 1 and 1. So I'll show you what I mean. All right, check out aluminum and oxygen. So that aluminum, that 3, is going to tell us that we have 3 oxygens. That oxygen, the charge on the oxygen, is going to tell us that we have 2 aluminums. So you crisscross these charges, take that 3 there, that 2 there, you have aluminum oxide. There you go. All right, look at another example. Barium, sulfur. Crisscross your charges. That 2 goes to sulfur. This 2 goes to barium. But 2 and 2 you can reduce to lowest terms. So you end up with barium sulfide, BaS. Reduce 2, 2 to 1, 1. You can't reduce 2 and 3. All right? Indium and bromine. That 3 on the indium goes to the bromine. The 1 goes to the indium. Now you don't need to write 1. You can just leave 1s out. So InBr3. Bam. There you go. Polyatomic ions, you just pretty much treat the exact same way, except for you get them off of the yellow sheet, and you can't change what the polyatomic ion is, and it doesn't factor into your reduction either. And so you just need parentheses if you have more than one polyatomic ion. So let's show you what I mean. 2 is going to tell us I have 2 SO4s. 2 tells us I have 2 bariums. Crisscross, then reduce 2 and 2 reduces to 1 and 1. Bam, you're done. A little bit more complicated when you're dealing with magnesium and nitrite. 2 means you need 2 NO2s. 1 means I need 1 Mg. So the Mg is easy, just Mg. But 2 NO2s, how am I going to show that? If I put 2 NO2, 2, that looks funny, and I need to show that I have 2 of all of it, so I put in parentheses. Mg, NO2, 2. Parentheses around the polyatomic ion. 1 and 1 crisscrosses. They're 1s, nothing changes. You just write what you got. Check out this. 4 and 2. 2 SNs, 4 SO4s. 2 and 4 can reduce to 1 and 2. So instead of a 2, I'll have 1 SN, and instead of a 4, I have 2 SO2s. SN, SO4, 2. And this is probably easier to see when we do this in class too. So just stick with me for right now. You can have 3 Cr2O7s, 2 Fe's. Need parentheses around the Cr2FO7. And the same thing here with NH4. You're going to have 3 NH4s. And notice that my polyatomic ion formula never changes. I can't reduce it. It doesn't change. Like this up here, you can't combine those things. You can't combine like terms or anything like that. And you can't, that 4 and that 3 don't match up. It tells you have 3 NH4s. So that means you have 3 nitrogens and 12 hydrogens, because 3 of everything in the parentheses. All right, so just some examples here, how we name these guys. All right, so if you have single charge cations, that means elements that you know what their charge is. So elements in group 1, elements in group 2, elements in group 3 with anions that came off the periodic table. Single charge cations, as I just said, 1, 2, 13, and then silver is always going to be +1. Cadmium and zinc will always be +2. Use the name of the cation and use the name of the anion. Now, anytime you write the name of the anion, you change the ending to "-ide." You always change the ending to "-ide." That's the only thing you got to do. Normal name off the periodic table for the cation, ending to "-ide" for the anion. Okay, so let's check it out. Sodium, fluorine, sodium fluoride. Barium, oxygen, barium oxide. Sodium, oxygen, sodium oxide. Now notice I don't say anything about the 2 because the 2 came from the charge. I don't need to say anything about the 2. Barium, fluorine, barium fluoride. Once again, don't even mention the 2. All right, so how about write the formula, give the name? All you got to do is find your guys, find the symbols for the 2 types of ions, and then crisscross for your charges. Silver, Ag+1. Sulfide, sulfur minus, I don't have my periodic table in front of me, sulfur -2. Crisscross your charges. Ag2S. Bam, there it is. Zinc phosphide. Zinc's a +2. Phosphorus is a -3. Crisscross your charges. 2 goes down, 3 goes down, zinc 3, phosphorus 2. There it is. Calcium +2, iodine -1, crisscross. 2 iodines, 1 calcium, CaI2. There you go. Now for the multiple charge cations, this is called like the transition metals. Your transition metals, you don't know what their charge is. So you have to be able to tell the charge. So what you're going to do is you're going to add some Roman numerals. Multiple charge cations are all your transition elements, and then lead and tin. Lead and tin are both in group 14 at the bottom. You don't know what their charges are. They're also multiple charge cations. So to figure out to name given the formula, you're going to figure out the charge on the cation, write the name of the cation, write in Roman numerals to show that cation's charge. This is called the stock system of nomenclature. So for FeO, you're going to have iron. We don't know its charge, but we do know the charge on oxygen. We know we're going to have iron, we know we're going to have oxide, but you can't have these two guys here with the same exact name. So you're going to need a number in the middle that tells you the different charge on iron. So we don't know the charge on iron. We do know that oxygen is a -2 though. So that -2 would crisscross down. It didn't give us anything on the iron, so we reduced from a 2 to a 1. There's a 1 right there. 2 became a 1. Well, oxygen's also a 1, so the charge on iron is also a 2. Iron 2 oxide. Check out this next one. You don't know what the charge on iron is, but we know oxygen is a 2. That 2 crisscrossed down and gave me 2 irons. Gave me 2 irons, yep. How many iron? What's the charge on iron? There's the 3. Crisscross it back up. Iron 3 oxide. Same thing with copper. Copper, bromine's a +1. You have crisscross back up and down with 1s. Copper 1 bromide. This one right here, copper 2 bromide. And this is a whole lot easier when we do examples in class, so don't let this scare you too bad. Going the other way is actually way easier because the names, you're just going to write the symbols for the two types of ions and you balance the charges because the names give you the charge, so it tells you what to crisscross. There's cobalt with a +3, chlorine with a -1, crisscross and make you jump. The 3 goes to the chlorine, the 1 goes down there, COCl3. Bam, got it. 10,4 oxide. 10's got a +4 charge. Oxygen's got a -2 charge. Crisscross and make you jump. 4 on the oxygen, 2 on the 10, reduce down. 2 and 4 reduce to 1 and 2, SnO2. Sn +2, O -2, 2 and 2, reduce down, SnO, 10,2 oxide. Now for polyatomic ions, all you have to do is just throw the name of the polyatomic ion in there. And for the polyatomic ions, you just get the name straight off of your yellow sheet. And so I'm just going to fly past this because this is just straight up off your yellow sheet. Nothing to worry about at all. The charges, everything comes straight up off the yellow sheet. Because I want to get to covalent compounds quickly for you here. So covalent compounds, once again, 2 types of nonmetals, and you'd have no charges. Since you have no charges, you don't have anything to crisscross, so you need to tell you how many things you have, and the key is the charges do not matter, so instead you're going to use Greek prefixes. So you got to memorize your Greek prefixes. 1 mono, 2 di, 3 tri. Those are all really easy. You've been doing them forever. Now 4 may be a new one. Not quad, tetra. And the easy way I remember tetra is because there's a really cool video game called Tetris where every piece is made of 4 blocks. Tetra is a prefix meaning 4. 5 is penta, 6 hexa, 7 hepta, octa, nona, and then deca for 10. You got to memorize your Greek prefixes. These are not on the yellow sheet. This is something you've got to get. And really, other than tetra, most of them are pretty self-explanatory. So let's look at some examples. Carbon dioxide. How many carbons is that going to be? 1. How many oxygens is that going to be? Di means 2. CO2. This is going the other way. Carbon, once again, how many oxygens is that? 1. Carbon monoxide. Now, if you notice, you don't put mono in front of the first thing. You put mono in front of the second thing. You never put mono in front of the first thing. Next up, dinitrogen trioxide. How many nitrogens? 2. How many oxygens? 3. Dinitrogen trioxide. Then here we have 2 nitrogens, so dinitrogen again, but instead of trioxide, this is pentoxide. And you just make it sound right. It's not pentaoxide, it's just pentoxide. Dinitrogen pentoxide. Carbon, 1 carbon, tetrachloride, 4 chlorines. And then finally, nitrogen, 1 nitrogen, 3 iodides. This one sounds kind of funny. Nitrogen triiodide. Whoops, going backwards. Nitrogen triiodide. And I'll leave you here with dihydrogen monoxide, a tale of danger and irresponsibility. Dihydrogen monoxide is a poison that you just have to bring up whenever we talk about this section in chemistry. And it's a major component of acid rain. It's found in every cancer cell that's ever been in existence. If you inhale dihydrogen monoxide, it can kill you. Excessive ingestion can result in all kinds of symptoms such as frequent urination, bloated sensation, profuse sweating. It is a major component of just about every poison in existence, and yet it's not banned. There's nothing out there that's stopping it, and it's an industrial byproduct of chemical reactions. Also, people dump it into rivers and lakes all the time, and yet it's still out there, still a danger to society. And hopefully by now you've looked at these up here and saw dihydrogen, 2 hydrogens, monoxide, 1 oxygen, aka H2O. Yeah, don't really think that's a big deal, but it just kind of shows you how things can scare you when you use chemistry words sometimes. I hope my video kind of helped you a little bit. Hopefully I will see you soon, and if you drink, don't drive.